Welcome to Semiconductor News Decoded. I'm Ty, with 31 years inside the semiconductor industry, bringing you the real view from the factory floor. Today's topic: Resonac's liquid encapsulant patent for AI semiconductor packages has survived every challenge thrown at it, and the patent has been officially maintained. A materials patent filed a decade ago is now sitting at the very center of the AI chip revolution.
As always, I'll explain everything in the most simplified way possible. Even a middle schooler should be able to follow along. If you're a specialist watching, some parts may feel oversimplified, but I'd like to prioritize giving everyone the big picture first. Today's analogy involves a confectionery maker and their secret cream recipe, and why timing can turn a quiet invention into a gold mine. So sit back and enjoy.
Here's how I describe today's news. Imagine a confectionery company that developed a very special cream recipe about 10 years ago. A cream with a uniquely balanced texture that wouldn't crack or deform no matter how much the temperature changed, yet stay just flexible enough to hold everything together. At the time, nobody paid much attention to it. The company just quietly held on to the recipe. But recently, it turned out this cream was a perfect fit for a particular type of luxury cake. And suddenly, what had been a forgotten recipe became an incredibly valuable piece of intellectual property.
The cake this cream was destined for is a highly delicate, multi-layered millefeuille. The more layers you add, the more problems arise during baking. The pastry can warp, the layers can shift, and the whole structure can fall apart. This special cream had exactly the right properties to suppress that warping and shifting, making it the perfect filling for an increasingly complex and demanding product.
Once all other manufacturers realized how valuable this cream was, they immediately said, "We'll make the same thing." They challenged the patent, arguing it was invalid, that similar formulas had existed before and the patent should be revoked. But despite a total of 8 separate challenge attempts, every single one was dismissed. The patent has been maintained through all 8 rounds. What I find truly fascinating here is that when this recipe was first developed, nobody imagined this style of luxury cake would ever become so popular. That's the thing about patents. Their value isn't set in stone when you file them. It's determined later by where and how the technology ends up being used. The companies that invest carefully in developing and protecting their technology today are the ones that end up holding enormous competitive advantages 10 years down the road.
Now let me map this analogy directly onto the real world. The confectionery maker is Resonac. The special cream is their liquid encapsulant material. And the high-end millefeuille is the 2.5D package used in AI semiconductors. From here, I'll walk you through exactly how this plays out in the real world of advanced semiconductor manufacturing. Let's get into the full technical breakdown. The company that holds this patent is Resonac, a Japanese integrated chemical manufacturer. Resonac was formed through the merger of Showa Denko and Hitachi Chemical, and it holds a top-tier position globally in semiconductor materials. Within the encapsulant resin category specifically, the company has deep expertise in materials designed for leading-edge packaging applications. The patent in question covers a packaging technology called 2.5D packaging, which is used in AI semiconductors. In a 2.5D package, the main chip, such as a GPU, and high bandwidth memory, or HBM, are placed side by side on an intermediate substrate called a silicon interposer. This architecture enables extremely fast data transfer between the chips, which is exactly what AI computation demands.
HBM stands for High Bandwidth Memory. It's a high-performance memory type built by stacking multiple DRAM chips vertically. HBM is used in AI accelerators like NVIDIA's H100 and B200, and demand has exploded alongside the generative AI boom. The 2.5D structure that co-packages HBM with a GPU on a single interposer has now become the standard architecture for leading-edge AI chips.
One of the biggest challenges in 2.5D packaging is managing warpage and mechanical stress. The resin material, known as encapsulant, is used to fill the gaps between chips and between chips and substrate. During manufacturing, the entire package goes through heating and cooling cycles, and this thermal cycling can cause the package to warp.
If warpage occurs, electrical connections can break and the chips themselves can be physically damaged.
What Resonac has patented is the specific formulation technology for a liquid encapsulant that reduces this warpage and internal stress. This type of liquid encapsulant is also known as underfill. It's a material that flows into the narrow gaps between chip and substrate and then cures in place. The exact composition and ratio of ingredients directly determines the warpage behavior and long-term reliability of the package. That formulation know-how is the core of this patent.
The priority date of this patent is 2016, meaning the original application was first filed back in 2016. That's before the generative AI boom and before HBM became widely adopted across the industry. In other words, this technology was developed well before AI semiconductors exploded in popularity, and it's only now, as the market has shifted, that the patent has taken on enormous value. For context, the specific patent number referenced in this news, filed as a divisional application, was submitted in 2024, but it traces its priority back to that original 2016 FIBOR.
Across Resonac's portfolio of patents related to liquid encapsulants for AI semiconductor applications, a total of 8 opposition challenges have been filed, and every single one has been dismissed, with all patents maintained. The specific patent in this news, number 7687499, is one of them. A patent opposition is a formal procedure in which a third party petitions the patent office to invalidate a patent. The sheer number of challenges filed against Resonac's patents tells you just how commercially critical these rights have become.
All 8 challenges were rejected, and the patents were maintained. When a patent survives an opposition, it means the patent office has once again confirmed that the invention meets the standards of novelty and inventive step, that it is genuinely new and non-obvious, and deserving of legal protection. For Resonac, this outcome legally reinforces the competitive strength of their technology.
Looking ahead, the advanced packaging market is expected to continue moving toward chiplet-based architectures. Chiplets involve breaking what would have been a single large chip into multiple smaller specialized chips that are then interconnected within the same package. This approach improves manufacturing yield and reduces cost, but it also makes the internal package structure more complex, and that raises the technical bar for everything the encapsulant has to do.
High BM stacking heights are also increasing. HBM3 primarily uses 8-layer stacks, but HBM4 and beyond are expected to push that number higher. More layers mean greater total height, which creates larger height differentials between adjacent components in the package. This makes it harder to control encapsulant flow and the stress state after curing. Resonac's formulation technology may be well positioned to address these increasingly demanding requirements.
Japanese materials companies supply a wide range of specialty chemicals and materials that are indispensable to advanced semiconductor manufacturing. From my experience on the factory floor, I believe this position is exceptionally strong and difficult to displace. Competing through materials rather than through equipment or chip design is a fundamentally different form of competitive advantage. Resonac's patent portfolio is a textbook example of that kind of strength.
Let me take a moment to pull everything together. Resonac holds patents on a liquid encapsulant technology used in 2.5D packaging for AI semiconductors, and those patents have now survived a total of 8 opposition challenges. 2.5D packaging is the architecture that places a GPU and HBM side by side on a silicon interposer. It's the standard structure in today's AI accelerators. Managing warpage and mechanical stress is one of the central challenges in this architecture, and Resonac's liquid encapsulant technology directly addresses that problem. The priority date goes back to 2016, before the AI chip boom, but the technology has become critically important as AI semiconductor demand has surged. With 8 opposition challenges dismissed and all patents maintained, the validity of these rights has been clearly confirmed. As chiplet integration deepens and HBM stacking heights increase, the value of this technology is likely to grow even further.
Let me wrap up. The real story here is that a resin patent with roots in 2016, before generative AI, before HBM became ubiquitous, has emerged as a genuinely critical asset in the AI semiconductor era. The value of a patent cannot be accurately measured at the time of filing. That value is determined later by how the market evolves and where the technology ends up being used.
What's particularly notable is that Resonac didn't simply patent liquid encapsulants in general. They secured rights around a specific performance profile, tailored to the demands of AI-focused 2.5D packaging, and that precise targeting is likely the reason all 8 opposition challenges have been turned away. This is a reminder that even in what looks like a quiet corner of the materials world, intellectual property can sit right at the heart of competitive strategy. It's a story that really makes you appreciate the long-term depth of what Japanese materials companies bring to the table.
That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.